Okay, good morning. So this will be our asynchronous class. So good morning since it's morning as I made this video, but you can access this anytime you want. Anyway, we're already on nomenclature of organic compounds. Nomenclature meaning naming compounds. Nomen is naming and clature I think is compounds. So organic compounds, as I've told you, um, naming compounds is just as recognizing them in any usually for you what would be the immediate use of this is you can recognize them in biochemistry in biochemical subjects or related subjects. Organic chemistry is of course a basic chemistry for all those allied sciences. So where was I think um, this will be a series of videos for nomenclature. So I think we've already talked about functional groups. You can just use that table during quizzes and exams because I really don't want you to memorize things. Okay, functional groups. So organic compounds are categorized into different groups according to their functions. Meaning, there are parts when you have an organic compound. There are parts wherein that part will function as somewhat. It will belong to a group, and those groups will react or um, will function in a certain way. So that's why they are categorized. So that those are functional groups. We have a table for that. Um, Maybe we could just you can always go back to the table. Anyway, this is just a review, and we have also talked about organic substituents. So one main thing in the main thing in organic nomenclature really is identifying the parent because it somehow identifies uh, the general structure of that organic compounds. But if you already knew the parent, you have to identify the substituents. As I've told you, kung paghahaaton, panyakan, ang gitatawag ng mga sanga. So if we've already identified the main stem or the parent, so those that are not um, part or maybe included in the parent is we call them substituents. So still, it will still have that pattern: one carbon, two carbon, three carbon. But anyway, we will just be familiarized with up to 12 carbons. So that would be met for one carbon, ethane for an alkane, and if it's already a substituent, meaning a sanga, so it will be named as methyl, ethyl, propyl, butyl, pentyl. So you have that YL instead of um, the common parent name. Okay? And then lastly also, I think we've already discussed alkanes, alkenes, alkynes, and cyclocompounds, meaning cycloalkanes, cycloalkenes, and cycloalkynes. So they are somewhat related. So we've already talked about that. We've also have examples of that. So now we are ready to proceed to the next organic compounds in line. We have alkyl halides, arenes, alcohols, and phenols. So generally, alkyl halides, as the name implies, so it is a combination of an alkyl group, a substituent, common substituent, which is an organic compound, alkyl. Okay, that dropping just the for methane, that would be a methyl. But there is also the halide part. The halide are the halogens. From the name alone, alkyl halides meaning it's an organic compound with substituents, alkyl substituents, and halogen substituents. Meaning halogen are the chlorine, fluorine, bromine, iodine, and astatine. So in basically, to name those substances, those substituents with chlorine would be called chloro something. So it's not like the alkyl wherein you have to drop the parent ANE for alkane and then you substitute it with YL For halogens, you drop the last name and then the last part, I think 3 letters for chlorine. So basically, if you have chlorine, CHO, CHLORINE, you drop the INE and then you substitute it with the uh, RO, chloro. For fluorine, again, drop the INE and then it would be fluoro. Bromine would be bromo. So dropping again the INE for iodine, dropping the INE, that would be iodo. Okay? So those are the common halides. So that is for an alkyl halides. Anyway, we'll just be having examples from that. Then we have arenes. So from the functional groups, we know that arenes is containing that benzene ring. Okay, the cyclic or the cyclo compound which has double rings, so they are called arenes. They are not cyclo compounds. They are somewhat cyclo compounds, but they are not considered a cyclo. So they are called arenes. Some authors call it aromatic group. Okay, when you talk about aromatic group, benzene group, arene group, or arene, it is talking about that six carbon chain in a loop wherein it has an alternating double bonds. And from our perspective of um, a perspective of the what do you call it? The localization of your electrons for arenes is the concept of resonance. So we know that from resonance, um, actually, as projected by applications, we are limited drawing them in alternating fashion, but with the concept of resonance, we know that those double bonds are distributed all throughout that six hexagonal rings. Okay, and then next to it are nomenclatures of alcohols and phenols. Alcohols, basically for your parent chain alcohol, you only have to drop the for methane ANE, you drop the ANE into an OL. So for a one carbon, that would be methanol, and two carbons, that would be ethanol, etc. For phenols, basically phenols are arenes with alcohols. So basically, if you have a benzene um, with an OH with it, so basically you only have to drop the uh, the um, the benzene parent name into NON. Okay, but anyway, we'll have examples of it. So this will be our topic today: alkyl halides, arenes, alcohols, and phenols.